Right now, let's start with stage 2 of our tutorial. This is about how to do the basic setup of a hybrido simulation. We will be creating the grid fluid container, setting up the emitters, adding some daemons like gravity. So let's start. So first we need a new grid fluid solver. This is by clicking on the grid fluid menu. This is this one here. And we need a domain. So the grid fluid domain is virtually a three-dimensional coordinate grid, and the units of the grid you can see by looking here at the little squares in the sides. This is one grid unit, and the this is the minimum resolution that you'll be having in your fluid. For example, if you have a collision with an object, this collision can not feature finer details than the one you're seeing there. First, we need to scale this thing. For scaling, I press 1 on my keyboard, then I have the top view. Pressing 1 gives you top view. You also can do this by doing the right mouse click view top. I'll be selecting the grid fluid domain again, and I have to scale this proportionally so that it will fit the grid fluid domain. Unfortunately, that is bad. You can see what's doing here, but all the whole parts of the domain. So if your computer is not the fastest one, or you don't want to wait forever when doing a simulation, then you could probably do it a bit smaller. I'll be saving some space here too, because well, we will not be seeing this part with the camera, so I don't need a fluid container for the parts that we do not see. And so this should do it, I think. And we also need to make it a little bit bigger, I guess. A bit smaller on the sides could do so. Also, something like this. And then we press 2 on the keyboard. This gives us side view. You can also go there by right-clicking view side. And we'll have to scale it in Y sufficiently. I think something like 19 could do it. Move it a bit upward. Oh, that's fine. This is virtually our container. So, in opposition to RealFlow's standard particles that you can still access here, the standard emitters, this fluid, the hybrido large-scale fluid, will only be existing inside this box. It's not possible that any fluid will escape from this box. This is because there is a completely different algorithm underlying the simulation engine, and this is important to know. The other thing that's very important to know is that the algorithm that's underlying the grid fluid domain is faster than the particle one. With the standard particles, you could have great detail in the fluid. You could see very fine stuff, you have really nice motion, but if you need high amounts of particles for simulating, for example, a scenery like this one, the simulation will take ages. Even it might take you days. And, we do not have days in most cases. So here we do not need very much detail for the fluid that is crawling along here. You do not need much detail for some water that's 2 meters under the sea ground. We will have different options for creating the details and for the simulation steps. But considering detail, the standard resolution when you're creating fluid like this is 100,000. This is very low. Yes, it is. So what I did in my simulation is that I just entered a 0, and then this is 1 million. And well, 1 million is still very low. If I was doing a job like this for production, for example, I was using 10 million or even 15 million. You can see when you're using 15 million, these squares here are becoming very little, so there will be more detail in your fluid. Don't make the mistake. Many people are making the mistakes because you'll be seeing some marker particles illustrating you where there is fluid and where there is air in your container. We do not have the particles, we have the fluid. This is just existing in the grid. The particles are just a visual representation, but it is not like the standard RealFlow particles. So, we're using 1 million, and you see there is a large difference. But I think for testing, 1 million is alright, or for testing, if you're doing your first simulations, also 100,000 might be sufficient. One other thing, compressibility, I'll be setting this to 1. Also very important because we want our swells to move fast, and for anything that's moving fast, put your compressibility to 1.0. I could give a scientific talk on all those parameters, but I think it's not the time yet to do so. So this is our basic fluid container, and well, now we have to fill it up, and this is in the next step.